Hi everyone, welcome back to my channel. If you are new here, welcome. If you are a returning subscriber, welcome back. If you are new, don't forget to subscribe and be part of our family. And before we start with today's topic, please don't forget to like this video, share with others, do subscribe if you are new here, and follow me on Instagram for some extra motivation. You can see my Instagram handle on the screen, and do let me know if there is a topic you want me to cover, if you have any queries, and any feedback is always welcome. Without further ado, let's get started. So here we are going to create a function to create a recursive function for factorial. Find factorial of a number using recursive function. That's the statement. Okay, and so let's start with the factorial first. So what is a factorial? This is how it looks like. So if you want to find factorial of 4, it's going to be 4 multiply you are going to multiply 4 with 4 minus 1, so that is 3, and then you will multiply 3 minus 1, 2, and then 1, so it's 4 into 3 into 2 into 1, right? And you can't have 0 here, because if you multiply this whole term, if you use 0 in multiplication, it's going to result in 0, so we don't include 0 here. And side note, factorial of 0 is 1. Okay, so 0's factorial is always 1. 1's factorial is always 1, right? So this is how you calculate factorial of a number. And the function that we're going to create is a recursive function. So you already know this function is going to call itself, right? Now this function is going to call itself. So we also need a base part and a recursive part. So this is obviously, this one is recursive part, this one, because the function is calling itself. Name of the function, how do you know if the function is calling itself? Name of the function. So name of the function is fact. You're using fact parenthesis inside the function, meaning function is calling itself. So function is calling itself, this is the recursive part, and this one is going to be the base part that will actually cause termination of the function. Okay, all right, so the logic is very simple. We're going to have a recursive part where we are going to return, so you are returning, we are going to just look at this statement, these statements for a second. So we have 4, 3, 2, 1, right? So 4 is the number that we are dealing with, and so we want to go down the line, right? So 3, 2, 1. So you are going to return 4 and then factorial of 3. I mean, if you look at this statement, so this is factorial of 4, right? So 4, 3, 2, 1. But this is also, if I exclude this part, 4, this is also factorial of 3, 3 to 1, right? And in 3's factorial, if you exclude 3, this is factorial of 2, 2, 1. And if I exclude this part in 2's factorial, this is factorial of 1, right? So this is the logic that we're using in recursive part here. So we are returning 4 and then factorial of 3. So how can you find factorial of 3? Just call this function again, and instead of having 4, now you can have 4 minus 1. So value of n is 4. It's going to be 4 minus 1, that's 3. Next time it's going to be, so this is how it's working, return 4 and then factorial of 3. And in 3's factorial, we have 3 factorial of 2, right? And this is how it's being calculated. So return 4 and then factorial of 3. And when you're calculating factorial of 3, you already had 4, now you have 3 multiplication and factorial of 2, right? So when you're calculating factorial of 2, you already had 4 and 3, and now you also have 2. And when you're calculating factorial of 2, you already had 4, 3, and 2, and now you also have 1. Okay, so that's how it goes, and in the end it's going to have 2 minus 1, so factorial of 1, and when we have fact 1, it's going to go to this part. Obviously it will go to this part even when value of n is 4. So when n was 4, it's going to compare n and 1. This is going to go false, so it's not going to return n, and it's going to go to this block here and all these steps. And then we have 1, factorial of 1. This is true, so it's going to neglect this block and it's going to go to this part and it will return 1. That's it. We're not calling any we're not calling recursive function again, so it's going to return n. That's 1, and you have the result. Okay, so let's create a program to find factorial of a number, say n, and if n is 1, we're going to return n. Otherwise we're gonna have again fact, you're right, n minus 1. Okay, and yeah, so you can actually, when you're calling this function, you can add multiple statements. So you can also have a statement where you go like, if the value of n is 0, you cannot find if value of n is 0, factorial is 1, right? So for that you don't have to call recursive function. You can just use that statement inside your normal code, and then you can create another condition for else block, that if value of n is if value of n is 0, factorial is 1. Otherwise you can call the function, you can call fact function. I'm not doing that, I'm just going to use random numbers. So randomly I'm gonna pick first 4, so factorial is 24. Then let's say we have 5, 120, fact of 2 is going to be 2. Let's see, fact of 1, right, and a big number, let's say 10, right? So this is your factorial function using recursion. If you have any doubt, please let me know. I'll see you in the next video lecture. Till then, take care.